objective, zero and negative exponents. Complete the chart. You're going to want to pay attention to any patterns that you start to recognize. 2 to the x power. So we have 2 to the third power, which is 8. 2 times 2 times 2 is 8. 2 to the second power is 4. 2 times 2. 2 to the first power is 2. So as you see this pattern, each time we step down in our exponent from 3 to 2, what's happening is we're dividing. 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2 is 1. 1 divided by 2, 1/2. 1/2 divided by 2, 1/4. 1/4 divided by 2 gives us 1/8. So each time we step down with our exponent, we are dividing by our base, which is 2. Similarly, we have 10 to the x power. So if the exponent is 3, we have 10 to the third power. 10 times 10 times 10 is 1,000. 10 to the second power, 100. So 1,000 divided by 10 is 100. 100 divided by 10 is 10. 10 divided by 10 is 1. 1 divided by 10, that's 1 over 10 or 1/10. 1/10 divided by 10, 100. And 100th divided by 10 is 1 over 1,000. So again, each time we step down, we're dividing by what our base is. And in this case, it's 10. So we have 5 to the third power. 5 to the third power is 5 times 5 times 5, which is 125. 5 to the second power, 5 times 5, 25. 125 divided by our base, which is 5, gives us 25. 25 divided by 5 is 5. Now we have 5 divided by 5, which is 1. 1 divided by 5, our base, is 1/5. 1/5 divided by 5 is 1 over 25. And 1 over 25 divided by 5 is 1 over 125. I hope you start to see the patterns that we have 2 to the third power and 2 to the negative third power. These are reciprocals of each other. If we have 8 over 1 and we flip it, we get 1 over 8. 2 to the second power and 2 to the negative second power. 4 and 1/4. We flip 4 over 1 and we get 1 over 4. You can do that for any of these that are opposites of each other. 5 to the third power, 125. 5 to the negative third power, 1 over 125. Same applies with 10s. 10 to the second power is 100, and 10 to the negative second power is 1 over 100. Vic number 1. For every non-zero number x, x to the 0 power is equal to 1. A non-zero number, that just means any number that is not 0. So our variable is x, and any number raised to the 0 power will give us 1. So for example number 1, 3 to the 0 power is 1. Example number 2, x times y, that quantity, to the 0 power is 1. Example number 3, negative 4.6 to the 0 power is 1. Example number 4, 7/5 to the 0 power is 1. Any number raised to the 0 power is 1. Vic number 2, for every non-zero number x, x to the negative a power can be rewritten as 1 over x to the positive a power. So when we have a negative exponent, we can basically flip it upside down and change the sign. So when it's a negative exponent, it moves to the denominator, if it's in the numerator, and becomes positive. We have to have a placeholder for our numerator, which is 1. So you can see some examples. Example number 5, 2 to the negative third power, which is 1 divided by 2 to the positive third power. Example number 6, c to the negative fourth power becomes 1 over c to the positive fourth power. Example number 7, 3x times y to the negative fifth power. So we have 3x, and this doesn't have an exponent that's divisible, so it's 1. We leave it alone. y to the negative fifth power becomes 1 over y to the positive fifth power. Now, this has an invisible denominator of 1, and when we multiply two things together, or two fractions, we multiply tops and then we multiply bottoms. So 3x times 1 gives us 3x, and 1 times y to the fifth is just y to the fifth. So this would be your answer simplified. Simplify. Example number 8. 6 to the 0 power. Anything to the 0 power is 1. Example number 9. 4 times x to the 0 power times y to the negative second power. And although you don't see those multiplication signs, because they're written next to each other and nothing's in between them, it's implied that it's multiplication. So we have 4. X to the 0 power is 1. Y to the negative 2 power, that's going to become y on the bottom and a positive 2. So 1 over y to the second. We can multiply this together. 4 times 1 is 4, times 1 is 4, over y to the second power. Example number 10. Negative 5 times x to the negative fourth. So again, negative 5 stays the same. X to the negative fourth would be rewritten as 1 over x to the positive fourth. Negative 5 times 1 is negative 5 over x to the positive fourth power. Example number 11. 2/3 times x to the negative sixth power. So 2/3 is our fraction, and we treat it just like we did negative 5. It's a constant, it stays out front. X to the negative 6 would be rewritten as 1 over x to the positive 6. 2 times 1 is 2. 3 times x to the 6, so 3x to the 6th power. You see that 3 and the x to the 6 are both in the denominator, so they stay together in the bottom. Example number 12. 1 divided by 4 to the negative third power. So here we have our negative exponent in the bottom. It's going to move to the top and become positive. Whereas here we had our exponent with a negative in the top, it moved to the bottom and became positive. This one's in the bottom, that's negative. It moves to the top and becomes positive. So it's invisible over 1, but we don't need to write that. Now we can simplify. 4 to the third power was one of the perfect cubes that you had to memorize, and that is 64. Evaluate. That was one of our definitions. When A equals negative 2, B equals negative 1, and C equals negative 3. So we're going to substitute. Whenever we see A, we're going to plug in 2. Whenever we see B, we're going to plug in negative 1. And then whenever we have C, we're going to plug in negative 3. Example number 13. 4 times A to the second power. Well, A is 2. So instead of A, I'm going to put 2. It's to the second power because this is to the second power. B is negative 1. To the 0 power. 0 power, 0 power. 4 comes down. 2 to the second power is 4. Negative 1 to the 0 power. Anything to the 0 power is 1. So I have 4 times 4 times 1, which is 16. Example number 14. 5 times A to the negative third power. So before we try to evaluate, let's rewrite it as 5 times 1 over A to the positive third power. So we've gotten rid of our negative exponents, and now we're going to do the evaluate process. So we're going to substitute 2 in place of A. So 5 times 1 over 2 to the third power. 2 to the third power is 8. So we have 8 in the bottom. 5 times 1 over 8. 5 times 1 is 5, and 8 is in the bottom. So 5 over 8. And this fraction cannot be reduced, so that will be our final answer. Example number 15. 6c squared divided by b, this is a b, to the negative 1 power. So let's rewrite this. 6c squared. And remember, if we have a negative exponent in the bottom, it's going to come to the top and it's going to be positive. So b to the first. Now we can evaluate. We've gotten rid of our negative exponents. 6, instead of c, we're going to plug in negative 3. It gets squared. And you must use parentheses. You take the variable out and you put parentheses around whatever you're substituting. This 2 goes on the outside. B is negative 1. And the 1 for the exponent is on the outside. Now we don't have to write a positive 1 exponent, but it was from where we moved it to the top. So let's evaluate. 6. Negative 3 squared. This means negative 3 times negative 3. A negative times a negative is a positive. So this is 9. And negative 1 to the first power. Anything to the first power is itself. So that's negative 1. 6 times 9 times negative 1 is negative 54. And our final example, example number 16. Negative 2a to the negative third power times b to the negative second power. Let's rewrite this to get rid of our negative exponents. So this would be negative 2 times 1 over a to the positive 3 power. And since b is to the negative 2 power, it will become 1 over b to the positive 2 power. Okay. So now we're going to substitute. Negative 2 is still out front. 1 over a, which is 2, so 2 to the third power. And b is negative 1, so negative 1 to the second power. And I have double parentheses, that's okay. 1 over 2 to the third. This is 8. Negative 1 squared, negative 1 times negative 1 is positive 1. So I have negative 2 times 1 over 8 times 1. Negative 2 times 1 is negative 2 over 8. And this fraction can be reduced to negative 1 over 4. This answer is negative 1 divided by 4.